And good evening, everyone. Welcome to this week's live chat. We have quite a few things to talk about this week. And as always, tonight we'll go over some of the details and then answer any of the questions that anyone might have in the premium chat and, of course, in YouTube. If, of course, we don't have any questions, then I'm going to go and cry about the Mets. So what else can I do this season? But in the meantime, let's focus on what is happening in the atmosphere. There's a lot of stuff evolving here that's kind of giving us a signal of what we might be looking for in the cold season, and a very interesting setup that is evolving for tomorrow that is unique compared to what we've been seeing for much of the warm season, i.e., an actual interaction beginning of a phase between the subtropical and polar jet streams. So first of all, obviously the talk of the town is our El Nino. Very interesting El Nino developing. Currently, a Nino 3.4, it would be considered a moderate El Nino. If you go by Nino 1 plus 2, it's very strong. The question is, does Nino 3.4 also shift into a strong phase? Now, currently, a lot of the focus is towards the Eastern Pacific, but the model guidance is suggesting a gradual shift towards more of a basin-wide evolution. And the forecasts are rather aggressive. These are the various models that we use, from the BOMA, which is basically the Australian version, to Canadian, European, GMA. You get the idea. Of course, you got NOAA, UK Met, and then this is the mean. And for August, it suggests that there would be a nice gradual jump. September even more so, and then October it really peaks out, and then November and December it starts to slow down in terms of the warming. And the mean expectation, the mean average of the evolution of this El Nino would suggest somewhere around 2.2 degrees Celsius above normal in Nino 3.4. This leads to the question of if this verifies, and I say if because of what we're seeing with the convection evolving here, it would suggest that there's a lot more focus on lifting towards the date line and points to the west. And when you take a look at the MJO, it's pretty quiet. And when you take a look at the SOI values, yeah, they're falling, but the 30-day average and the 90-day average are nowhere near what you would expect for a strong El Nino. They're more for a weak to moderate El Nino. So the atmospheric response is not as robust as one would think with sea surface temperatures like that. You know, where you're talking about 3.4 degrees Celsius above normal in the eastern zones. You would expect the SOI to really start to really get invigorated, maybe get around a sustained minus 10 to 15 at this stage. So it's interesting that we're seeing that. Why is that the case? I think there's a lot going on here in terms of the influence in the stratosphere and what we're seeing with the QBL. So we know that obviously the SOI is falling, so obviously we get more and more of an El Nino influence on the pattern, just not as robust as one would expect for a strong one. But even more importantly, if I can find the data, we're seeing a slightly cold stratospheric environment. Let me zoom in on this. You can see it's slightly below normal. During this time of year, we don't see a huge variance in the temperatures because we're still getting more direct sunlight. But we're moving away from that. You could see as we head through the summer months and head into September and October, you see that range increase as the direction of the sun moves away, and we get less direct heating from the sun during the winter months. So we're seeing slightly cool, and the reason why we're seeing that is because of the introduction of all that water vapor in the stratosphere. Remember what I've been talking about. The introduction of all that water vapor in the stratosphere leads to a cooling, contraction, as a result, an expansion, warming in the troposphere. This doesn't mean everybody's warm. It means that the heights overall are enhanced. Now let's take a look at the QBO. The QBO has been steadily falling and is heading towards a negative state. All right, now the latest measurement for July was 0.06. Okay, so it's essentially neutral. And when you take a look at the observations here, what you want to do is look above 30 millibars, because the QBO evolution sinks south, sinks down towards the surface, right? So you have all this negative state here. Why is that a big deal? Well, I've been doing research on El Niños, especially strong ones, and the relationship with QBO states. And thus far, I've only come across one strong El Nino with a negative QBO state. And in that environment, and it kind of gets tricky because we have atmospheric changes and shifts, aside from global warming and all that stuff, but that influence from the volcano is a big deal. What's unique is that when the QBO was negative with a strong El Nino, it led to strong negative EPO and negative NAO signals. And we're seeing constantly in our 500 millibar pattern this evolution of an upper level low around the Aleutians constantly redeveloping. And we're seeing that also in our long range guidance as well. So how do we handle this? We know that there is a significant warming factor in the troposphere. And we know that that's altering the way that we've seen convection developing around the globe. If I can pull up the right picture for once. And here we are. So we know that this should be here and this should be more active, but it's not. We know that the Atlantic is pretty much acting as you would expect. Indian Ocean is a little bit more active than one would expect. So there's a slight shift here. And that slight shift is altering the interaction of tropical convection on our pattern, which is amplifying the whole polar jet stream, which increases the potential for interaction of short waves. It increases the potential for high latitude blocking. And then you throw in the stratospheric environment of a QBO shifting towards a negative state. And I think you can kind of see what the possibilities are. Now, there's still a lot of wildcards and uncertainties to look at for the fall and winter pattern. So I'm not comfortable enough to make any declarative statements, but I don't think taking the average El Nino forecast and just saying El Nino equals this, much like La Nina didn't act like it normally did last year, the same thing can be said this year. And we need to be prepared for a lot of unusual evolution in this pattern, which makes the volatility and chaos in the seasonal forecast exponentially high, because we're just now starting to get a better idea of how that volcanic influence with all that water vapor is starting to impact the different circulations in the atmosphere from the stratosphere to the troposphere, and that circulation is enhancing various circulations in cells like the Hadley cell in our mid latitudes in the tropospheric level, which is creating a lot of chaos. So as we study all this stuff, I want you to be aware of that chaos so you understand what our limitations are and what's actually happening here, because it's pretty profound and interesting. Now, for our current pattern, this all plays into what I was just describing. So now you understand what the background is, right, of this whole evolution of the pattern. Then we look at the water vapor satellite picture. And boy, oh boy, this is fun. This kind of takes me back to flashbacks of when I was a kid and watching the Weather Channel and watching Jim Cantori with the water vapor satellite picture. I was like, oh my God, this is an amazing tool. I didn't even know this existed. What's great about the water vapor is that you can see the various parts of the atmosphere and how they're interacting. You can see the polar jet stream, the subtropical jet stream starting to interact and play together. Now, there was a question this morning. I was mentioning this in the premium and also public forecasts. Exactly how is this shortwave going to interact with this one, and whether or not it's going to push everything further east? We now have a pretty strong idea, not just with the model agreement, but with the observations, that this deep trough in the polar jet stream associated with this upper level low will interact with this shortwave in the subtropical jet stream with all of this moisture in such a way to support a wave of low pressure to march basically across the Philadelphia metro through central New Jersey, through Long Island or just south of Long Island, and then through southern New England. And what that will do is support an area of strong lifting. So what you want to do is take a look at the 700 millibar shortwaves here. So let's go down to tomorrow afternoon, 700 millibars. We'll zoom in. And you see this evolution right here with this slight negative tilt that's showing up here. What this tells me is that this area right here is going to experience some pretty strong stretching in the atmosphere. And this area down here is going to support some elevated convective precipitation. Because when I take a look at my buff kit data using the NAM and HRR and RAP guidance and kind of mix that together and kind of take a look at the various features and how each model, because it's a mesoscale evolution, how they're handling that forcing. When you combine those factors, you can see that there's a good potential for elevated thunderstorms over the Philadelphia metro through central New Jersey. That's going to support heavy rainfall, nothing severe. If you're looking for severe thunderstorms, probably have to head down towards, let's say, the Delmarva and Virginia. Anyway, in this scenario, you have this evolution of the mid-level lows. So there's 700 millibars starting to take shape. But even more impressively is 850 millibars. And man, this takes me back to some cold season forecasting here. We're starting to get a little bit of a practice here, because what's happening is that as these features are interacting and starting to phase together, you're starting to get this development of your surface low intensifying, and then your mid-level low intensifying, and then your upper level features intensifying. And so what this is signifying is rapidly rising air. And when you get this 850 millibar low developing, that's when you start to get your heavier precipitation showing up to the north and to the west of the 850 millibar low. And you can find the same thing when you close off the 700 millibar low, because in these areas, this is where you're stretching the atmosphere and you're allowing rapid ascent in the atmosphere. Remember, the stronger you could raise the air, the stronger that air rises into the upper portions of the atmosphere, the stronger you end up with lifting and heavy precipitation. Finally, let's take a look at 850 millibar temperatures. And look at that. Nice little thermal gradient setting up here. Not excessive in any way, shape, or form, but for this time of year, it's pretty robust. I mean, it's a nice polar air mass. So now you have the potential for frontogenesis, which is another form of lifting. So now we have 3 different forms of lifting all coming together. And how about I throw in a 4th one? What the hell, right? So here's our 4th one. Low-level jet stream dynamics. So what this will do is transport plenty of deep moisture into the region. So we have a combination of all these factors. This supports a widespread rainfall event with heavier pockets of convective precipitation. So when you have these heavier pockets of convective precipitation, you want to be really, really careful with your mesoscale guidance, because what it'll do with each run, and for example, this is the NAM guidance. Let's go with 12Z, because everyone seemed to be excited about 12Z and then weren't so excited about 18Z. Why is that the case? Well, the 12Z just produced a ton of heavy precipitation, very convective precipitation over southern New England. 18Z, my least favorite model period, but let's use it. Not as impressive. What is the difference? potential convective feedback, and the evolution of the 850 millibar low on the NAM guidance. I would not use any of these models verbatim. And when it comes to winter forecasting, I also would caution against doing that, because what you have here is a lot of rising motion in the atmosphere, and the models are trying to handle where the mesoscale banding or mesoscale lifting is happening, and then therefore where the mesoscale sinking is happening. A slight adjustment either way can fundamentally change your forecast. So the best way to go about this is to say, okay, widespread moderate heavy rainfall, pockets of intense rainfall, this area, which is what we highlighted, Connecticut, let's say, okay, let's go southern New England, let's say around Cape Cod, through Rhode Island, Connecticut, New York City Metro, including Long Island, Hudson River Valley, and much of New Jersey. And then you can kind of clip the Philadelphia Metro. In those areas, because we know synoptically where the 850 millibar and 700 millibar low is forming and how the troughs are interacting at 500 millibars and where our jet streaks are at 850 millibars and 250 millibars, synoptically, that is where you'd have your best potential for rising air and enhancement of mesoscale factors. Then you take that and you say, okay, this area is where we can expect a half an inch to an inch and a half of rain with locally higher amounts depending on where those embedded thunderstorms set up. So that's how you handle this situation. The worst thing you could do as a meteorologist is try to be perfect. And trust me, it took me a long time to learn this. Because you always want to be right. You want to kind of gloat, you go to social media, I got it right, I nailed it, blah, blah, blah. Long term, though, if it doesn't make you have a complete headache and just go completely insane because perfection is impossible, more likely than not, you will create an erroneous forecast because you're trying to be too perfect. And that's nearly impossible to do because it's basically chaos. So I like the idea of a moderate to heavy rainfall setup around the region, and this evolution shows up nicely also as well on the European. Again, there is still some question as far as where the heaviest bands are going to set up, but you can see the general agreement with the low pressure track on all the model guidance. So I'm pretty confident in that. And again, if you're using precipitation maps, this is the GFS. You can see, okay, there's that theme. Let's pull up another one. How about the HRR? Let's see where that shows up. And we'll try... Does this go far enough out? No, let's try 18Z. And that one. Now look what the HRR does. Again, don't take this verbatim, but this is cool, right? Because what it's trying to do is trying to find those little convective pockets. So here's a convective pocket, and then kills the rainfall to the north and south of it. There's another convective pocket, kill, kill. Another convective pocket, kill, kill. So you're getting all these different convective pockets showing up in the model guidance. Now, are you going to use this and say this is what's going to be verbatim? No, of course not. But it gives you an idea of what the potential is where these embedded thunderstorms set up. Basically, you can enhance your rainfall rates to 1 inch per hour at times. So it kind of gives you an idea of what the potential is as far as the heaviest rainfall, but I wouldn't use any of this guidance verbatim. This is why you don't use precipitation maps or snow maps, by the way, from model guidance. This is why you make your own, because more times than not, you're going to end up with some of these errors. So that is the evolution of the pattern that I'm seeing right now. Oh, by the way, I know I didn't say much about the tropics. There is absolutely nothing going on. Nothing. Absolutely dead. I mean, it is as dead as a doorknob can be. You have one little wave here coming off the African coast, but guess what? Dry air is killing everything. Absolutely everything. And the only time where the model guide shows any type of tropical development is out in Fantasyland. European Fantasyland shows maybe a tropical wave developing in the Central Atlantic. And of course, our friendly GFS produces a storm in the Bahamas that just kind of pinwheels around and lifts up the coast and merges with Godzilla and blows up an entire city. So as you can see, the GFS/Murphy-Kane solution is still alive and well and should be ignored. So with all that being said, we'll pull up the radar data as we watch this evolution, and I will get to answering. I'm doing good tonight. Answering all of the questions you might have. First, of course, from the premium section. All questions will be asked in the premium section for premium members, and the best questions are taken from the YouTube and Twitter if there are any. We'll pull that up here in just a moment. There we go. Okay, so first, what do we got here? Really strong 250 millibar jet streak running from Southeast Asia all the way up to the Canadian Pacific Northwest. All right, let's pull up the jet streak, shall we? Let's see here. That should be model guidance. This one. Okay, so 250 millibars. We'll zoom out. Hello, Earth. There we go. Very impressive little jet streak here. Now, this is all driven by the evolution of that convection that we're talking about, and also some tropical systems starting to interact with the polar jet stream. Warning: if the polar jet stream develops a strong jet streak that slams into northern North America, let's say around British Columbia, that would be a zonal pattern and a very mild pattern for much of the country during the fall and winter months. If we get this upper level low to drop south, right now it's expected to kind of meander around Russia and Alaska here for the next couple of days during the 10-day period, supporting this jet streak here. So don't be surprised if after we get some of our polar air masses, we get a little bit more hotter towards the middle and end of the month. But this evolution is pretty much textbook of what you would see during an El Nino year. Very impressive one at that. Do you think models might be over-exaggerating on El Nino given the sea subsurface temperatures? Okay, he's talking about this. Let me pull this up here. If I can find it. There we go. Here we are. Okay, so let me scroll down here. As I've been talking about this a lot, this feature right here, where the subsurface is cooled, it's kind of leveled off in the latest observations, but you can clearly see there's some more cold pockets showing up. Typically, when you see this type of signal, you would see a slowing down of your El Nino state. In a La Nina, it's the exact opposite, where you start to see this warming starting to take shape. This is how we knew that La Nina was coming to an end, finally, after 3 years. So this signal certainly is not one that would suggest strengthening. And is there a potential that the models are being too aggressive? Possibly. What I would say is this. If we get a Kelvin wave to rock and roll, and there are some indications that will happen, that would cause the subsurface to rocket up and spike, and that would lead to a warming throughout all the insular regions. And it looks like that's what the model guidance is trying to key on. If that Kelvin wave does not mature and develop as expected over the next couple of weeks, and it's supposed to set itself up in the next 4 weeks or so, then you have to start to ask some pretty significant questions as to whether or not we're dealing with a strong El Nino event. Certainly a moderate event at this point. I don't think you could call it weak in any way, shape, or form in terms of the sea surface temperatures. Then there's the question of the SOI and the convection, and that's where the things really get complicated with the overall seasonal forecast. Saw the GFS 18Z run is trying to spin up a hurricane off the southeast coast. Of course it is. In the 10 to 15 day period, usually the time when it does the convective feedback fund, but it is in the area where it seems development might be something where we can get and avoid the basin-wide shear. Is it possible? Okay, so let's have some fun and pull up the GFS here. If it loads, it might not. Oh, there it is. Okay. So how does it pull it off? Okay, so apparently, I see what it's doing. Okay, so it produces this stalled trough here, and that could certainly support a wave of low pressure developing along it. So it takes a, see, this might not even be a tropical system. Take a look at the way that the precipitation setup is evolving here. If anything, it would probably be a subtropical low, because you got dry air coming in on the backside of this. All right, now I'm curious. Let's take a look at 850 millibar humidity during this time period. There's certainly some sinking air here, possibly warm core low, some dry air involved. There's a short wave interacting, getting ready to interact with it. Let's see what our thermal gradient looks like. I'm trying to see just how warm core this actual warm core would be, just for fun, just to see what exactly the GFS is trying to do here. Okay, so there's our frontal boundary stalled out. There it is. Okay. Warm core, cold core. So you have warm core low, clearly in the middle of this, and a cold core circulation on top of it. So this is probably some sort of subtropical storm, if the GFS was actually right. So pretty interesting stuff definitely in place here. I believe the GFS is trying. Is it going to be raining all afternoon tomorrow? That's a great question. Okay, so the expectation is that we'll see some pretty steady rain after 12. Okay, the idea here, and I like the timing of the European the best here. The GFS, I mean not the GFS, the NAM isn't far off either, but I don't like the intensity of it. But as you can see here, once we get to about noon, we start to see rain becoming widespread, go through 2 o'clock. By the time we get through the evening rush hour, we start to calm down. And by about 8 o'clock, most of the Philadelphia metro is dry, probably some drizzle and spitting showers here and there. New York City metro is heading that way. And Long Island and Connecticut still has rain through about, let's say, 9:30, 10 p.m. So it will certainly feature plenty of steady rainfall tomorrow. The afternoon hours look to be rather wet. Or if you have plans in the evening, you want to head out, whatnot, shouldn't be a washout. So after 7 o'clock from, let's say, Queens on westward through eastern Pennsylvania, you're fine. East of Queens, Connecticut, not so much. Periods of rain. Setting up here. I've seen people saying that we are in for a treat during the winter months. I hear that every year. Actually, I have not heard a year yet where someone has said it's going to be the most epic winter ever, and then they compare some sort of epic winter to this one every year. Every year. And I always say beware of fool's gold and people promising epic winters, especially without concrete data. I would say this. El Nino winters typically have a lot of fun in them because you have a lot of interaction with short waves, you get a phasing scenario just right, and you can get a pretty epic storm. With that said, if we have a strong El Nino, you have to have the high latitude blocking being nearly perfect. And we all know about nearly perfect, don't we? Where, okay, we have a negative NAO, but it's more east-based. That could certainly happen. I don't know yet, but it could certainly happen. We have a weak polar vortex that splits, but the strongest shortwave, you've heard of this before, goes to China or Europe or down towards the Central Pacific, and we miss out on it. Okay? Um, so I would be very wary of anyone suggesting epic winters on the way because there's too much we don't know. I mean, even in an average year, it's too early to say anything definitively because there's still a lot of questions. You have to check out the snow growth. You have to see the sea ice evolution in the Arctic, how that's evolving. You have to see how the polar air masses are building in Canada and in Asia, and how those features are evolving. Whether we're seeing a lot of deep cold cores or if we're seeing a disruption in broken polar air masses, and then there, of course, that's just the average year. Okay, then you have that influence from the volcano, as you know. I mean, geez, the research being done here, and one model, one research that came out, one paper came out, still needs to be peer reviewed, but basically, it was showing how the convection that we're seeing now, and what we saw with La Nina, what we're seeing with El Nino, the interaction of all that water vapor in the stratosphere has displaced the rising motion in the atmosphere, and because of that displacement, we're not seeing the traditional lifting parameters in terms of convection in the Pacific. And then they tried to roll that forward for the fall and winter and years beyond that for about a 3 to 7 year period, and it produced well above normal precipitation on the East Coast, near to slightly below normal temperatures on the East Coast. It also produced well above normal temperatures, let's say, in the desert Southwest. Basically, it enhanced all the extremes because you had a warmer troposphere in place, so your ridges were enhanced and the heights were more enhanced, so your troughs were more enhanced to balance out those differences with the ridges, and the model guides they used basically tried to work with that evolution, but it's not peer reviewed yet, and there's still some questions about how they went about writing the equations and the physics involved with that report. But it was very interesting. At least gave us an idea of what to expect and the type of road we should go down as far as that potential. But this is going to be another year, like I warned last year. Last year I learned a lot. I learned that volcanoes can create all sorts of havoc, especially when they throw water vapor. The difference between last year and this year, though, is that last year the water vapor was moving and we weren't sure whether it was going to get into the northern hemisphere and what would happen once it does, how much does it interact and spread out. Now we're kind of at a stable state in terms of understanding the water vapor involved. Now it's a question of, okay, the water vapor's here, we know it's in place, how is it impacting the atmosphere as a whole? We know that it is a natural major global warming impact. It will definitely raise our global temperatures because that's what water vapor does. So how does that interaction play out in the way that our storms evolve and the jet stream dynamics? And a lot of uncertainty goes into that, and it's a heck of a challenge. It's a lot. It's a lot of fun to try to figure this stuff out, but it would be irresponsible for me to be saying that I'm confident of X, Y, and Z. Tornado watch. Will tornado watches happen for the rest of? It's possible. It's August. Of course, there's a chance. Why has there been only 5 named storms when NOAA predicted an active hurricane season? Well, I sure didn't. Okay, so the NOAA forecast, from what I understand, and from from Colorado State, was based on the idea that we have a lot of warm water. Warm water. World's going to end. Blah, blah, blah. But they also assumed that El Nino would take off slowly and that the shear and dry air would have less of an impact. I strongly disagreed with that and went with a below normal season. So we'll see how that works out. And then I'll review at the end of the hurricane season. I'll do it on a live chat. Say, okay, here we are in November. This is what we had. This is what I forecasted. This is what everyone else forecasted. Let's look at what happened. So I don't want to jump the gun on that because late August and early September, you can go from dead quiet to 5 named storms in a very, very short period of time. So I don't want to jump the gun, so to speak, on that. But a lot of the influence I thought would be in place with that dry air and vertical wind shear has done a heck of a job. On the flip side, though, when a tropical low pressure system has been able to develop, it has taken that warm water, that fuel source that is enhanced, and utilized it. And then these storms were able to reach hurricane status when normally they wouldn't in this type of unfavorable environment. Are there potential conditions favorable for another heat wave? Definitely in the Philadelphia metro. We should see a relaxation in the pattern because this is a pretty active one, so we should see it towards the middle of the month. So I definitely like the idea of temperatures being in around 90 to 95 at some point, especially around the Philadelphia metro during that time period. But one caveat here is that the last time we had this set up, the model guidance was going 99, 100. Some places didn't even break 90 because of all the thunderstorms and whatnot in the area. And the substance in the region wasn't as strong as what we thought. So that could be a little bit of a cautionary sign here, especially now that we're moving into August and we're starting to move away from the strongest support for heat waves. Still there, but it's reduced, right? Certainly compared to the middle of July. So it's interesting that the last time we had any type of hint of that potential, that we didn't reach those maximized temperatures. That basically those maximized temperatures were focused more down towards the southern Atlantic and southeast. So that's certainly something that I'll be watching and seeing how that plays out. Outstanding questions once again from everyone. I really appreciate it. Let's see what we're dealing with the radar here. And as you can see, our storm is organizing here. Plenty of precipitation. Let's pull up the water vapor. Let's update this and see if we got anything new that could be interesting. And of course, we're waiting for it to load. There it is. Okay. So you see this area right here and this right here. These two are timed just right to interact with each other right around here. So we should see these two interacting with each other by about 7 a.m. tomorrow morning, right around here, given the speed and the evolution of both of these features. So if that is the case, then the forecast is going to verify pretty nicely here. Let's see if we got any new NAM guidance coming in yet. Might be a little early, but let's check it out and see if we got anything new. This is why I can't wait for when our clocks fall back. Nope, not yet. But yeah, I mean, everything I'm looking at here certainly would suggest a verification of some moderate to heavy rainfall. Let's take a look at the infrared satellite picture, and you can see that lifting starting to expand and grow. So you could certainly see the evolution of this pattern all taking shape and the setup for tomorrow. All right, not bad. Very good questions tonight, guys. So with that, I also want to bring up before we end tonight the fact that I got put on a board. This is pretty cool. The American Meteorological Society board. For a while now, I've been involved in conversations with various other meteorologists from the American Meteorological Society about how to develop a seal for the work that I do here. Okay, we didn't really fall under TV because I don't work for a TV station, and it doesn't really fall under the CCM because that's more like forecasting for Exxon and stuff like that. So we came together and we started to talk about what a new seal would look like. And I've been working with various other meteorologists who are absolutely amazing on how to develop that seal, the tests involved, uh, and I helped put together what will be this new seal. And one of the things I made sure to do is that yes, you have to have a degree, but it's fair, in that when you show your work, you don't have to have like the best graphics. You don't have to have the TV graphics, although some people on YouTube really impressive graphics, but you don't need that. What you need to do is be able to tell a story about what's going on with the weather, explain it, but not in a sensational manner. Like forecasting Arctic blasts in the middle of the summer and stuff like that. So the idea is that to give recognition to, and there's a lot of meteorologists out there that don't necessarily work for a private company, work on their own, or have built their own companies, consulting, snowplow drivers, road crews, transportation, but on a smaller scale, and also the general public, and to give that recognition and that trust. So that's the goal of the seal. I'm definitely looking forward to earning it because I think that it's perfect, right up my alley personally, and it's really exciting. And I hope to help as many people as I can earn it and move forward with it. But the reason why we did is that I felt, and other people felt that there was a gap. That hey, look, there's a lot of people coming out of college don't want to work for a big company, want to work on their own. Guess what? With everything out there, you could do it. You could build your own platform. So there comes the certification. So I was asked if I would like to be on the board of this new certification. It's a 3-year term, and or a little over 3 years. And I'm really looking forward to helping as many people as I can. I think it's going to be something that will be a really exciting part of my career. Of not just saying, oh, I got a seal, but that I'm able to help people and kind of leave, no matter what happens in the future, to kind of leave that mark of saying, giving other meteorologists the avenue that I didn't have to start out. And also weed out some of the individuals that let's just say are less than savory, putting out the worst case scenario or GFS guidance 10 days out or 15 days out and claiming, watch out East Coast, there's going to be a blizzard and all that nonsense. So hopefully we cut that stuff down and we get to share science and not sensationalism. Let's see here. You do a good job, but Pete hit a game-tying home run. Thank God, Pete Alonso has been really bouncing back. And I'm just going to touch off on this one thing with baseball. I get what the Mets are doing. I really, really do. And I really like the prospects. I really, really do. But for God's sakes, could we not have a 6-game losing streak? Could we at least try? So we'll see. And, half dozen the other, if they stay at the record that they're at, they're going to get a better draft pick. So we'll see what happens. So it is 8:45. I'll take the last questions. Thank you on the congrats on the AMS stuff. Reminds me of the winter storm chat. Yeah, I can't wait for our winter storm chat, especially in this setup. I'll have the buff kit data ready to roll, We'll have the chart ready to roll. Yeah.
Somebody on Twitter wants to know if severe Saturday is possible. They came in a little late.
Oh, okay. Severe thunderstorms for Saturday. I don't like it. And the reason why, and I'll pull up the 500 millibar chat for Saturday. Here we go. Okay, so this is Saturday evening. All of your forcing mechanisms are really focused more towards New England, and along with your strongest divergence and diffluence. Let me go a step right back to 78 hours. There we go. That's even better. Okay, so here's a shortwave coming in. There we go. Okay, so here's a shortwave coming in, right? It's slight negative tilt, but all your divergence and diffluence is up here. So what you want to look for is your spreading in the atmosphere. So think of the upper atmosphere like taffy. So you're stretching to taffy, right? And so when you're stretching to taffy, the air is rapidly rising. So as you're setting that up, your best lifting is up here towards central and northern New York. I can't rule out a thunderstorm on Saturday evening, but I would say the strongest vertical wind shear, divergence, diffluence, aside from maybe instability, is all focused up to our north. For our area, I like the idea of scattered showers, isolated thunderstorm. I can't rule out a severe thunderstorm, especially this season, but I think the best dynamics are to our north. How does early next week look? Active still. I mean, I'll keep up with the 500 millibar pattern here, and you could see that we continue to see shortwave after shortwave marching through next week, and I expect us to continue to see these waves of cold fronts. I don't see widespread rainfall events, but almost every other day next week we're going to have a threat for scattered showers and thunderstorms, and of course, as always, some of those thunderstorms could be of a severe nature. On Monday night into Tuesday, what really is catching my eye, but I think we're a little bit too far out to get into particulars. But notice how the trough here is a little bit more of a positive tilt. So you got this spread here. So this is sinking air here with the shortwave ridge, but you see all this spreading here. What I'm concerned about is you get like a cluster of thunderstorms setting up, and this rides right towards the Poconos in northern New Jersey with falling 500 millibar heights and a strengthening 850 millibar jet. That could be interesting Monday night into Tuesday. But we're still a little bit too far out to get into details, and things could change in that respect. But that's something I'm going to be keeping an eye on. Outstanding questions. How is it looking in Ohio? Well, unfortunately, this chat really doesn't focus on Ohio all that much. But if we look, well, you know, Ohio is a wonderful place. I know that.
It's a weird place, much like New Jersey.
Oh, that's true. They don't have good food. Trust me, I've been there.
They got some interesting things.
Yeah, but
How about the food, though?
yeah, well, I definitely say New Jersey food's better. Okay, so currently, right now, Ohio is about to get rather wet. There's a very impressive heavy rainfall and thunderstorms moving through portions of western Ohio. That's going to spread across the rest of Ohio overnight and eventually head towards our neck of the woods. Well, my neck of the woods, at least. Not your neck of the woods, because you're in Ohio. NFL preseason starts this weekend. That is true. I'm excited. I think you know what I'm excited about. Obviously, as you guys all know, I'm a Chiefs fan, so duh. But I'm really excited about the Jets and Giants this year. I think that they could have a good season, both of them. And it's not just because of QB and blah blah blah. They both have improved their offensive and defensive lines. I really like their schemes. I'm really interested to see how they do this year. Because even with the Chiefs, it all starts with the offensive line. Yes, you can have a great quarterback and all that stuff, but if you don't have blocking, it doesn't matter what your QB does. Okay? So you have to have some sort of blocking scheme. So I think that the Jets and Giants might actually surprise some people. So we'll see. We'll see what happens. It should be an interesting year. That is for sure. And of course, as you know, much like last year, I will be doing all the NFL forecasting for local teams, the Eagles, the Giants, and the Jets. And whether they're home or away. So Cowboys defense is going to be historically good. Yeah, I've heard that before though, but we'll see. I mean, it's certainly. I think they have a shot. I think they have a shot of. I think the Giants, the Giants, the Eagles, and the Cowboys are going to really have a real fight on their hands. It should be interesting to watch this season. I wouldn't sleep on the Eagles. That's all I'm saying. Obviously, because they went to the Super Bowl last year. All right, so I think that's it for tonight. Any other questions in Twitter?
No, somebody says the videos are great. Same person.
Thank you.
Congratulations on the thing. You know.
Awesome. All right, so we're going to call it a night because, well, it's 8:51. We're going to call it a night and get ready for this rainfall. And thank you, as always, for joining and following along. And I will see you tomorrow with our regular videos and discussions. In the meantime, stay safe out there.